Hello everyone, welcome to CS for All. So today we are going to continue with the AlgoMaster Sheet and we are going to solve the problem one integer. It is a problem from a website called Binarysearch.com and I won't reveal you the concept right now. So I will once read the question, think of the solution in your mind. If you can figure out the solution, that's great. If you can't figure out, do a hit and trial, try for 2 or 3 times to find the solution on your own. If you can't get to the solution, then you can continue watching with the video. So let's get started.
Audio Jungle.
Hi again. So this is a question. Let's read the question once. So you are given a list of integer nums. Okay, so we are given an array of integers. You can reduce the length of nums by taking any two integers. Okay, so we can take any two integers from the array, removing them. Okay, we have to remove those two integers and appending their sum to the end. Okay, and whatever will be the sum of those two integers, we have to append that value to the end of the array. Okay, the cost of doing this is a sum of the two integers you removed. Okay, so the cost of this operation would be the sum of the two integers which I removed. Okay, done. Return the minimum total cost of reducing nums to one integer. Okay, so I have to do this operation until the array size is 1, that is only one item in the array. Okay, so I have to find the minimum total cost of reducing. So after doing all the operations, whatever will be the value of the total cost should be minimum. Okay, fine. So let's go to the Miro board to understand one single example. So I will be taking this example 1, 2, 3, 4, 5. So I've taken this example. So let's see what does the question states once. Okay. So first the question says that we can take any two numbers from the array. Okay. So if I take 1 and 5, okay. So I will be removing them completely from the array. Fine. And whatever will be the summation of those two values. So 1 plus 5 equals 6, right? So I can add that 6 back to the array. So what will be the new array? The new array will be 2, 3, 4 and 6, right? Again, I can do the same operation. Let's say I removed 2 and 6 from the array. Okay, I removed 2 and 6 from the array. So what will be the sum of 2 and 6? That will be 8. And again, I add back 8 to the array. So what will be the array? 3, 4 and 8, right? Again I do the operation. Let's say I remove 3 and 8. Okay, I remove 3 and 8. So what will be the sum of 3 and 8? It will be 11, right? And again I add back 11 to the array. So what will be the array now? It will be 4 and 11, right? Now I have only two numbers, right? 4 and 11. So I have to remove them. So I remove them completely from the array. And what is the sum of 11 and 4? That is 15, right? So I push 15 back into the array, right? I push 15 back into the array. So now tell me one thing. I have only one number present in the array now. So all my operations are done. I had to reduce the entire array to a size of 1, right? So my operations are finished. Now what is the cost of the operations? Let's see. So the first cost was 1 plus 5, that is 6. Okay. The second cost was 2 plus 6, that is 8. Okay. The third cost was 3 plus 8, that is 11. Okay. The fourth cost was 4 plus 11, that is 15. Okay. And no, there is no fifth cost. Okay. So we have to add this costs 15, 11, 8 and 6. So what will be the summation? This 2 will add up to be 26. This 2 will add up to be 14 and this 2 will add up to be 40, right? So this is the summation. This is the total cost. And what does the question ask us to do? The question asks us to find the minimum total cost. Okay, the minimum which is possible. So let's understand the solution now. I hope you got the question and the dry run of this particular example. Now we will be moving on to the solution. Okay. Okay, so now let's start with the solution. So what were the numbers we had? 1, 2, 3, 4 and 5. Okay, now there are three possibilities. The first possibility is we can either pick two highest numbers each time, that is 4, 5. Okay, and we can carry on this process every time, that is pick two highest numbers among all the numbers. Okay, second possibility is we can pick, okay, let's say we have the numbers again, so we can pick two smallest numbers among all the numbers. So this will be 1 plus 2, right? So two smallest numbers among all the numbers in every operation, that is every step. And what can be the third possibility? Let's write the numbers once again. The third possibility is we can pick any random numbers. Okay, we can pick any random numbers. It can be 1, comma 4, or maybe 2, comma 5. We can pick any random number. So we will be seeing all the three possibilities. So I want to do this just to teach you how to do a hit and trial. Okay, like you will find yourself stuck in several questions where you cannot find a solution and you cannot think of an intuition. So you have to do hit and trial to find the exact solution. So we will do the very same thing here. Okay. So first I will go with the very first possibility, that is pick up highest numbers, two highest numbers in every operation. So let's say we have this set of array. Okay. So pick up two highest numbers. What are the two highest? 4 and 5. Okay. So I'll be writing the cost here at every step. Okay. Okay. So 4 and 5 would be 9. So cost would be 9. I eliminate them and I will be adding 9 to the new array. Okay. So 9 added to the new array. Again, what are the highest elements in this particular array? The highest elements are 3 and 9, right? So what is the summation of that? 3 and 9 would give me 12. Okay, so the cost is 12. I eliminate this 2 and I add up 12 here. Okay, I add up 12 here. Again, what are the two highest elements from the array? That is 12 and 2, right? So I add this 2 up, that would be 14, and I eliminate them from the array. Now I again add back 14 here. So we only have two elements left, so we have to add them up and eliminate them from here. So adding up 1 and 14 would give me 15, right? So I add back 15 here. Okay, now tell me what is the total cost here. Okay, so 5 plus 4 would be 9, 9 plus 2 would be 11, 11 plus 9 would be 20, then carry 2. So here it would be 50. So the total cost is 50. Okay, so it is a cost when we are adding two highest elements at every step. Now let's see what will happen if we add two smallest elements at every step instead of two highest. Okay, so let's say again we have the same array 1, 2, 3, 4, 5. Okay, now we will be adding every time two smallest numbers and here it will be the cost. Okay, so 1 and 2 are the smallest here at the very first type. So I eliminate them and I add them up. So 1 plus 2 would be 3. So I add back 3 to the array. Okay, so 3 comma 3 comma 4 comma 5, right? 4 comma 5, this is 4. Okay, so I add again 3 and 3. So what that would be? That would be 6. So the cost is 6 and I eliminate them and I push back 6 into the array. So what it will be? 6 plus 4 plus 5, right? Now tell me what are the two minimum elements? The two minimum elements are 4 and 5, right? So I add them up, that would be 9 and I eliminate them from the array. Okay, and I add back 9 to the original array. So that would be 6 comma 9. Okay, now since we have only two elements, we will have to add them up and eliminate them. So 9 plus 6 would be 15, right? And I add back 15 to the array. Okay, so what is the total cost this time? 15 plus 9 would be 24, 24 plus 6 would be 30, 30 plus 3 would be 33, right? So 33 is a cost when we are adding two smallest element at every step. And what was the cost for adding two maximum element? That was 50, right? So for smallest it's 33, for maximum it's 50. Okay, now let's check if we pick two random numbers. Okay, so let's take the same array example 1, 2, 3, 4, 5. Okay, and we can have the cost here. Okay, so let's pick up, let's say 1 and 3. Okay, so we pick up 1 and 3. So 1 and 3 would be 4, right? And I eliminate them and I add back 4 here. So 4, 2, 4 and 5. Okay, again let's pick up 2 and 5. Okay, let's pick up 2 and 5. So what that would be? 7, right? I eliminate those two and I add up 7 here. So 4, 7, 4. Okay, let's pick up 7 and 4 here. Okay, so 7 and 4 would give me 13. I eliminate them, and I add back 13 here, 4 and 13. Okay, fine. Then we have two elements left, so I have to add them up. 13 plus 4 would be 17, right? So I eliminate them and I add back 17 in the original array. So what will be the total cost here? 7 plus 3, 10, 10 plus 7, 17, 17 plus 4, 21. Okay, so 2 carrying, here 3, here 4. So that would be 41. Okay, so total 41 when we are picking random elements. So you can see the difference, right? So when we are picking two smallest element at every step, we are getting the minimum cost. The total cost is minimum in that case. But in case of picking two highest element from the array at every operation, that gives me the maximum total cost. So what shall we pick? What shall we pick? We shall pick two smallest element among all the elements at every operation. Okay, so how can we do that? We can do that using min heap, right? So I hope you already got the solution. I will describe the solution once more. So I will be taking up a min heap and I have the array, right? 1, 2, 3, 4 and 5. Okay, so I insert every one of them here. I insert every one of them into the min heap. I have 1, 2, 3, 4 and 5. Okay, fine. So what does min heap do? It helps us find the minimum element among all the elements present inside it. Okay, so what is the minimum element here? 1. Okay, so I will pop it from here. And what is the second minimum element? 2, right? So I again pop it from here. I add this 1 and 2, that would be 3, and again I insert it into the min heap again. So let's see what is the min heap now. The min heap would be 3 comma 3 comma 4 comma 5. So these two were popped last time, right? Now what is the minimum? 3 and 3 is minimum, right? The two most minimum elements. So I pop them out. I pop them out and add them. That would be 6. I eliminate this 2 and I add back 6 to the min heap. Okay, so what is the min heap now? The min heap would be 4 comma 5 comma 6, right? Fine. So what is the minimum element? What are the minimum elements? 4 and 5 are the two minimum elements, right? So I eliminate them, I pop them. Okay, and I add them. 4 and 5 would give me 9, right? And I add 9 to the min heap again. Okay, so I remain up with 6 and 9. Okay, I remain up with 6 and 9. So I eliminate both 6 and 9. I bring them out and I add them. That is 15. And I again add 15 to the min heap. So whenever the size of min heap would be 1, all my operations will be finished. And then what I will add, the addition will be 15 plus 9 plus 6 plus 3. Okay, so that will total sum up to be 33. So that will be the answer. So now that you know the solution, we can go straight to the coding part. Okay, so now let's start writing the code. So what do we need? What are the main components? The main component is a min heap, right? So we discussed in the STL video how to write the syntax for making a min heap, to create a min heap. Okay, so the syntax is like this: priority queue, then we have integer data type, then we have vector end, and then we have greater end. Okay, so this is how you make a min heap. Let's name the min heap basket, as I always do. Okay, one more thing: if the nums size, that is the array size, is 0, we have to return 0. There will be nothing, right? If num size is 0, we have to return 0. Fine. Now, what we have to do? We have to push every element from the array into the min heap, right? So what we have to do? We have to traverse through the array elements. So someone was very confused with writing auto in the last video. So I will be writing the general method for the loop. Okay, so nums.size I plus plus, and then we have to push the elements into the basket. So basket dot push nums at I. Okay, so all the elements are being pushed through this block of code. Fine. Now what we have to do, we have to take two smallest element from the heap in every operation until and unless the size of the heap is 1. Okay, so what we can do, while basket dot size is not equals to 1. Okay, until basket size is 1, we have to continue doing the operations, right? So I have written the same exact thing. Now let's say, okay, so where will we store the answer? We will store the answer in a answer variable. So let's name it answer and assign a value of 0 currently. Okay. So we have to add two smallest numbers, right? So let's name two variables left and right for getting those two numbers and then adding them up into a resultant number. Okay. So let's write left and right and a resultant to add those left and right. Okay, so left will be basket dot top. Okay, basket dot top. So the minimum element is assigned to left. Now we have to pop that element. So basket dot pop, we have to pop that element so that we can get the next minimum element into the right variable. Okay, so right equals to basket dot top and again basket dot pop. Okay, so what do we have here? In the left we have the number one minimum element, in the right we have the number two minimum element. Now we have to add the number one minimum element and the number two minimum element, and we will add that and put that value in the variable res. Okay, so res equals to left plus right, and then what we have to do, we have to push that resultant sum again into the min heap. Okay, so what we have to do, basket dot push res, and finally what will be the cost? The cost will be added up to the answer, right? And what is the cost here? Res is the cost here. So answer plus equals res. Okay, and then we have to return answer. Okay, let's try running the code. Okay, code is running fine. Let's try submitting the code. Okay, code is running fine, code is submitted. So yeah, that's it for today's video. If you had any doubts or queries while watching the video, you can comment down below, or you can directly reach out to us through LinkedIn, or you can join our Telegram channel. We have daily discussions over there. I personally try to resolve your doubts in there, so definitely check that out and join the channel. And in this video I tried to cover everything in detail so that you understand the intuition properly of why and how we are using the things here. So if you like the video, please consider dropping a like, consider subscribing to the channel and share it with your friends. So see you guys in the very next video. Till then, stay happy, stay healthy, bye.
Let's go. Yeah. I'm like an addict, do I gotta have it. I ain't even playing, got a really bad habit. If it moves, gotta grab it, fuse like a magnet.